Om Sri Sai Ram. Hearty welcome to Sri Sathya Loka Seva Gurukulam online classes in physics, electrical energy. So electric energy is one of the forms of energy, and even we also have got energy, electric energy. For example, if you rub the two hands, it becomes hot. How does it become hot? It is a static charge present in us. You might have heard in the olden days, there was, even now also, there will be self-realized what you call gurus. And those gurus used to touch the head of the disciple. So there will be flow of charges. And even now also, we are supposed to do pada namaskara for elders. Matru Devo Bhava means mother is God. Pitru Devo Bhava, father is God. Acharya Devo Bhava, teacher is God. Atithi Devo Bhava, guests are like God. So in Indian system, in our culture, we have a system of doing respect, giving respect. We touch the feet. When you touch the feet, there is transfer of charges. Of course, it is unseen. You cannot measure it. Especially when the parents say that you be happy, peaceful, loving, then that words itself will encourage us. Because same God is there in everyone. Is it not? So that charges will be there in all of us. That is the meaning. And we have studied in our previous classes about the electrical energy, one of the most important forms of energy. The transfer of this energy is very, very easy, and there is no house without electric energy, and we are using it for different purposes. I need not tell them, you know it. The bulb that glows, the motor that runs, the mixie that works, is it not? The television what you enjoy every day, and radios, tape records, iron box, boilers, not one or two, hundreds of gadgets we find. They are all products of electricity. There are two kinds of electricity. One is called as static electricity, which is present in the body, which can be got by rubbing of substances. And also there will be two types of charges, namely positive charge and negative charge. We have law of charges. What are the law of charges? Like charges repel each other, unlike charges attract each other. Suppose you have two positive charges, they repel. And suppose you have two negative charges, they also repel. Instead of that, if there are two unlike charges, these are called unlike charges, there will be attraction. So unlike charges attract each other, like charges repel each other. This is called law of charges. And it was Benjamin Franklin who said there are two kinds of charges. And the charges are measured by a device called, charges are detected by a device called electroscope. Scope means measure. Electro means charges. Okay. And the quantity of the charges is measured by a unit called coulomb. Is it not? And I also studied about Coulomb's law of electrostatic charges. The force of attraction or repulsion. This is an example of attraction. This is an example of repulsion. Is directly proportional to quantity of charges. Q1, Q2, for example, if you want Q1, Q2, and the force of attraction is inversely proportional to the square of the distance between them. That is called Coulomb's law. Combining these two, we have a very important formula. F is equal to K into Q1 Q2 by R square, where K is called the constant of proportionality. Q1 Q2 are the charges, R is the distance. So what does it mean? Lesser is the distance, more is the force. More is the distance, less is the force. That is called inverse proportion. Also, if the Q1 and Q2 are more, force also is more. If Q1 Q2 are less, then the product also will be less, and hence the force also will be less. How do you measure the quantity of charges? By a unit called coulombs. How do you measure distance? By a unit called meter. Okay, that is called as Coulomb's law of electrostatic charges, which you have studied in the previous classes. And now let us try to answer the home assignment. The first question is, define the unit of charge and electric potential. The unit of charge is what is called as coulomb. Potential is volts. You have to define it. What do you mean by 1 coulomb? So unit of charge is coulomb. 1 coulomb of charge is the charge which, when placed at a distance of 1 meter from equal like charges, repels with a force of 9 into 10 to the power of 9 newtons. That is the value of K. So it is a repulsive force of like charges. Then we have Q1 Q2 replaced by Q square by R square. So 1 coulomb means what? So distance is 1 meter. Distance between two charges is 1 meter, and the charge of say like forces will be, say for example, it is 1 coulomb. Then the force is called as the repulsive force, and the unit is 1 coulomb, COULOMB, named after the scientist. Okay, and this is the constant K. Value of K is 9 into 10 to the power of 9 newtons. What is Newton? Newton is the unit of force. Okay, that's how you define it. Unit of potential is volt. What is potential? 1 volt is a potential at a point in an electric field such that 1 coulomb of charge, say positive charge, is brought from outside the field to that point against the field when 1 joule of work is done. We have the formula V is equal to W by Q. What is W? Work done. Why do you want to do work? To transfer the charge. From where? From one point to another. And that is what is called as potential. So 1 volt means if 1 joule of work is done to move a 1 coulomb of charge. So this is what is called a coulomb of charge. Q is charge. And work, unit of work done is joule. And unit of charge is coulomb. Okay. So if 1 joule of work is done to move a charge of 1 coulomb from one point to another, then that work done is called as 1 potential, 1 volt. Okay. And how do you measure this volt? By a device called voltmeter, usually written as V. We have shown in the previous class, right? So this is the answer for the first question. Coming to second question, how does the force between two small charged spheres change if their distance is doubled? So R becomes 2R here. Q1, Q2 are the charges. How the force is changed, they are asking. The force is F1, let us suppose, is so much. Here distance is doubled, means it is far. Now what happens to the force? That is the question. Answer is Q1 Q2 by 2R whole square becomes 4R square. So 1 by 4th of F1. So new force is equal to 1 by 4th of the former force. Suppose it make it as 3, becomes 1 by 9. Suppose it is 4, 1 by 16, like that. Okay. So that is how the change of force, because distance is doubled. Now next question, one more problem we have. How will the force between two small electrified objects vary if the charge of each of the two particles is doubled and separation is halved? Separation is made half, R by 2, and charges are doubled. 2q and 2q2, it becomes 2 to the 4, 1 by 4 square becomes 1 by 2 square becomes 1 by 4, 4 into 4 becomes 16, q1 q2 by r square. So that is 16q1, 16f1. So answer is, now the force becomes 16 times more than the previous force. Okay. Now for today, we will see some of the interesting things. Let us start with some problems. We will see how many electrons make 1 coulomb. Coulomb is the name of the scientist, but you should know the value of a number of electrons. So if n electrons make 1 coulomb of charges, and how do you get charges? It may be excess, it may be deficiency. You have seen in the previous class, when a glass rod is rubbed against silk, silk will get more electrons. That we call it as excess. Whereas glass rod will lose electrons, we call deficiency. So anyway, that the unit is called coulomb. And 1 coulomb of charge means n into E. N is number of electrons, and charge of 1 electron is 1.6 into 10 to the power of minus 19 coulombs. It's a very, very small unit. Don't think it is a very big one. Minus 19. And so n becomes Q by E. Q is 1 coulomb by E is 1.6 into 10 to the power of minus 19. And the value will be, this is minus 19, this power should come here. And the value will be 6.25 into 10 to the power of 18 electrons. Okay. So that is the value. That means, so a number of electrons in 1 coulomb of charge means 6.25 into 10 to the power of 18. What do you mean 10 to the power of 18? 1 followed by 18 zeros. You can imagine how the scientists have done so much fine calculations. It's a very minute one. It's very difficult to do it. So you must appreciate the work of scientist. So always when some persons do some extra work or efficient work, you have to appreciate. Okay. Now let us see one more problem. Calculate the work done in moving a charge of 3 coulomb across 2 points having a potential difference of 24 volts. V stand for volts, C stands for coulombs. So given charge Q is equal to 3C. Here C means coulombs. V is equal to 24 volts. So what is work done? So work done is equal to Q into V. We have seen V is equal to W by Q, the formula. In this formula, W is equal to Q into V, where Q is the quantity of charges, V is the voltage or potential difference. So work done, Q is equal to 3 coulombs into 24 volts, becomes 72 joules. So work done is equal to 72 joules. Joule is the unit of work, also energy. Both have the same unit. This is a problem. And in this formula, if any two items are given, say V and W, you can find out Q. Or V and Q are given, you can find out W. Or V and W are given, you can find out Q. Okay. So that is an important formula. Now coming to electric current. What is electric current? Defined as electric charge flowing through a conductor or a metallic wire. It's also, that means quantity of charges flowing per unit time. So electric current is nothing but I, what you call it, is equal to quantity of charges Q by T. So make a list of all the formulas in physics. This is the second formula. I is equal to Q. Q means what? Charge. How do you measure it? In terms of coulombs. T means what? Time. How do you measure it? In seconds. What is I? I is the current. So quantity of charges flowing through a cross section of the conductor in unit time. That is called as quantity of charge, called as I. And how do you measure it? This is measured in a device called ammeter. And the unit of current is ampere, A, named after the scientist. What is 1 ampere means what? 1 coulomb of charge. So 1 coulomb of charge flows through any cross section of a conductor in 1 second. 1 coulomb of charge flows through a conductor in 1 second. We call that current as 1 amps. Shortly call it as amp, or full name is ampere. Is it okay? Why it is called ampere? Because the scientist who discovered this unit is ampere. So ampere, Andre Marie Ampere is a scientist who discovered this. So 1A is equal to 1C by 1S. C means coulomb, S means second. That is what is called as ampere. It is the SI unit of current in honor of the scientist, French scientist, namely Andre Marie Ampere. He was in the year, born in 1775, died in the year 1836. He is a French scientist who made a lot of discoveries in the field of electricity. If you also make discoveries, your name also will come. Okay, so try to do something new and give the contribution. Now, which device you use it? For example, potential difference is measured by a device called voltmeter. Atmosphere pressure is measured by a device called barometer. Temperature of a body is measured by a device called thermometer. So here we have got what is called as ammeter. So this is the device, ammeter. We write it as A. If you go to your shed, suppose you have a pump set. In the shed or in the meter, they will find out One is A, another is V. V means voltage. A means amperes, current. So here this is the index and it shows from 5 amps to 30 amps. How much current is flowing it shows. So that the device is called ammeter and the unit we are measuring is called amperes. Okay. And there will be smaller units of this current. For example, all electronic devices want small currents. We have milliamps. 1 milliamp is equal to 10 to the power of minus 3 amps. Microamps. 1 microamp is equal to 10 to the power of minus 6 amps. So there are smaller units of current. Okay, so an ammeter is an instrument which is on connecting the series in electric circuit indicates how many amps of current is flowing in the circuit. Voltmeter is connected in parallel. Ammeter is connected in series. So this measures current, that measures voltage or potential difference. What is a cell? All of you are very well known. A cell is one device which converts electric energy, chemical energy into electric energy. And there will be, chemical reaction taking place. So here the cell negatively charged plate repels the electrons which causes the electrons to move along the wire. So what you do? You take a wire, right? And there will be plus and minus. So this is to be connected by means of wire to the bulb. So the electrons will flow from negatively charged plate to the wire, through the wire to the positively plate of the cell. Is it not? And if we have more than cells, we call it as battery. So here the flow of electrons is called electron current. That is how the word current electricity comes. Current electricity means what? The flow of electrons from one place to another place. So conventionally the direction of the current is taken as opposite to the direction of flow of electrons. So in a circuit diagram we show it as from plus to minus, but actually electrons are moving from minus to plus. So note the difference is very important point. When showing in a circuit we show from plus to minus, but actually electrons are moving from minus to plus. So these are some of the symbols that are used in electric circuit. So if you have a cell, there will be one long line and small line. This is what is called as cell. This long line represents plus and this is the small line represents minus. So plus and minus becomes cell. If there are more than one cell, we have battery. This will be about 1.5 volts. A number of cells if increases, say for example there are 3 cells here. So 1.5 into 3. And this is called open plug. We also called a switch. That shows the closing of circuit and opening of cells. If you keep like this, it means open circuit. And this is closed circuit. Closed means what? That button is to be pressed. So this is on, this is off. So closed plug key or switch. And this is wire joined. This shows this is the connections. This is wire crossed. So these are symbols used in circuit. Please note it correctly. And if one circuit is passing over the other, wires crossing without contact, you show by this symbol. This is a symbol of bulb. This is resistor, about which you are studying later. A resistor. This is rheostat, means variable resistance. This shows how it can be varied. Ammeter, which I was telling you just now, and it measures the current. Plus and minus will be there. Galvanometer, which measures a small amount of current. That also shows current only, but small amount. Voltmeter shows the potential difference or voltage. Again, there will be plus and minus. Electromagnet means a magnet, a soft iron core or nickel or cobalt. When current passes through them, it becomes an electromagnet. and here it is a iron, in between, iron core. Then it becomes electromagnet with iron core. Okay, so these are some of the symbols we use. Also we use transformer. We are going to study that later. Step up and step down. There are two types. These are the two, circuits. So this between the bad conductor will be there. So separate them. This variable resistance that shows how the resistance will be changed, means rheostat. And this is open switch, another symbol used. And this is closed switch, another type of repairing. This is called inductor, and this is about which you are studying later. Tapping key, and this symbol stands for electric fuse, about which you are studying in the next chapter, heating effect. So you might have seen how they use a fuse wire, which will be for the safety of the electric circuits. This is capacitor. Especially electronic devices will have a capacitor. There will be, this shows this type now is called AC supply. What is AC? Alternating current. This is reversing key. So when you draw a circuit diagram, all these symbols are made use of. In some circuit we use less number. So if these symbols means, they must understand what does it stand for. A means ammeter, V means voltmeter, like that. Okay. And just now we are telling about the conventional flow of current and the showing flow of electrons. So electrons move from minus to plus. So this is minus. So electron will go like this, in this direction, and it comes through this. But while showing, we show in other direction. It goes like this, we say, and comes like this, we say. That is the difference. That is called conventional flow. So conventional flow is plus to minus. Electrons will flow from minus to plus. And that happens in the case of conductor. Now let us see what is a battery. Combination of many cells is called as battery. And here battery means it always carries DC, direct current, means which flows in only one direction. There are two types of current again. One is called DC or direct current, another is AC or alternate current. In direct current, the direction of flow of current will be on the same direction. Okay. And in alternate current, the direction changes. So batteries will give direct current. It is useful for small experiments and all. But in cars and all, you might have seen very huge batteries are taken. Do you know why it is so weight? A bus battery or a car battery, lorry battery and all. Why do they have so much weight? It is there. It is because there will be lead grids inside that. There will be solution inside, sulfuric acid, and the lead grids are there. The lead is very heavy. That's why the car batteries are very heavy. Okay. That is what is called as battery. So if you have more than one cell, we have a battery. And this is an example of a cell. And sometimes the cell will have more power also. You might have heard about 9-volt cell. Is it not? 12-volt cell, etc. Then it becomes a battery because there will be more number of cells. This is usually made up of nickel and cadmium. Okay. So that is about a battery. Now let us see what is meant by conductor. Are the materials which allow the flow of current through them freely. For example, metals like silver, best conductor is platinum. Then comes silver, then comes copper, then comes aluminum. Least conductor is iron. So insulators are the materials which do not allow electricity to pass through them. For example, rubber, current will not flow. Plastic, glass, bakelite, etc., etc. They do not allow the flow of electricity. Wood also, paper also, they won't allow. But metals like this are allowing. So all those who allow the flow of electrons are called conductors. Those who do not allow are called insulators. Okay. Now coming to a very important formula or law called as Ohm's law. Why it is called Ohm's law? You might have heard Om in spirituality. Early morning you are supposed to get up and do Om. Om is a very, very energetic mantra. It consists of 3 mantras: Brahma, Vishnu, Maheshwara, Auma. Those who chant it will always get a positive thoughts throughout the day. And you have a peace of mind. Most of the diseases also are cured. At least 21 times you are supposed to chant in the early mornings. Okay. So here this is a physics Om. What I told was spiritual Om. Coming to physics Om, according to Ohm's law, current flowing through a conductor is directly proportional to the potential difference applied across the ends of the conductor, provided temperature of the conductor remains the same. So this is important. Temperature remaining same. What happens? Current flowing through the conductor is proportional to potential difference. And removing this symbol, you have V is equal to Ri, where R is called the resistance. What is resistance? No, the blockage for the flow of electrons, we call it as resistance. I is the current, V is the potential difference. So very, very important formula. V is equal to Ri. So this is the third important formula in physics, in electricity chapter. First one was V is equal to W by Q. Is it not? And then came Q is equal to I by T. Is it not? And now you have Ohm's law, V is equal to Ri. In this formula, suppose you are given V and R, you can find out I. Suppose you are given V and I, you can find out R. So formula for R will be V by I. Formula for I will be V by R. So very important, and you will be having some problems also on this. Okay. And a dry cell, you call it as D, a voltmeter of range 0.15 volts, an ammeter 0 to 1 amps, and a standard is fixed resistance coil 1 ohm, rheostat which changes the resistance 0 to 1 ohm. Connecting wires and plug key are used to verify the Ohm's law. So verification of Ohm's law, this is the photo of George Simon Ohm, on whom the name is given as Ohm's law, who made a lot of experiments about the relation between voltage and current. So different, as you increase the voltage, current also increases. As you decrease the voltage, current also decreases. That is what is called direct proportion. And in between you have one constant called as resistance. A fixed resistor R, ammeter A is connected in series, and voltmeter should be connected in parallel. When the plug key K is open, the readings of ammeter and voltmeter are to be kept 0. Starting A and V should be 0. Okay. And now plug key K is to be inserted. First to keep it open, then you have to insert it. So when you insert it, what happens? The current will start flowing. And what does the rheostat do? Rheostat varies the resistance. You can just move it this side, that side. So by you can increase the resistance or decrease the resistance. What is resistance? It is the blockage of flow of current. It is the impediment on the way of flow of current. Okay. And what does the ammeter do? Ammeter will show the current. What does voltmeter do? That shows the voltage. Okay. So this is an experiment to verify Ohm's law. So value of current are to be increased with the help of rheostat, and recordings in ammeter and voltmeter are to be read again and again. So we have to go on changing, increasing amps current. So voltage also increases. If you decrease the ampere current, then voltage also decreases. So this is the circuit diagram. First you must know draw the circuit diagram. How to draw it? First start with the cell. If one cell is there, you could call cell. If you are more, usually we want 4 cells. What you call battery. 4 cells should be there, 6 volts current. And you will have one more device called as eliminator. Battery eliminator is usually used. Eliminator. That will be used in the laboratories, which gives about 6 volts. There will be a plug key in that. So A is the ammeter, it should be kept always in the circuit, and plug key just for opening or closing the circuit. Rheostat to change the resistance, and voltmeter should be connected parallel to this. So this is resistance. What does the resistance do? The flow of electrons is blocked by resistance. And here first you have to increase the flow of current. As you increase the current, the voltage also increases. That is what you can see from voltmeter. So ammeter shows current, voltmeter shows voltage or potential difference. Rheostat is used for varying the resistance. Okay. And the change in the resistance, change in the, the current A is marked on the x-axis and potential difference is marked in the y-axis. This is called 2 axes and this is called original. What do you observe? For every current you can mark with the potential difference. So we observe that as you increase the current, potential difference also varies. Like that, if you increase the voltage also, current changes. Like that you mark it and join it. You get a smooth straight line which shows that ratio of V by I is a constant. So it is a graph is to be plotted with the reading between ammeter and voltmeter after 4 to 5. Here I marked about 6. And it depends. Just go on changing the current. So also PD also varies. That you can plot it like this. So that is a verification of Ohm's law. So what do you observe? On increasing the current, namely ammeter reading, current on voltmeter also changes. That is potential difference also changes. And this graph is called voltage current graph. It is a straight line. Because the ratio will be same. So conclusion is, we conclude that the current flowing through a wire is directly proportional to the potential difference applied across the ends. That is Ohm's law. But one condition here is, you should not increase temperature. Temperature remaining constant. So V is equal to R into I. Where V is voltage, means potential difference, R is resistance, I is current. And how do you measure it? Voltage is measured in volts, resistance is measured in ohms, and current is measured in what? Amps. Okay, now we will come to the home assignment. Define the unit of current. Name the instrument to measure current and potential difference. Why is a conductor different from an insulator? when the potential difference across a wire is doubled, how will the following quantities be affected? So what you are doing? Potential difference is doubled. That is V is doubled. What happens to resistance? What happens to current? That is the question. Okay, come prepared very well. Thank you.